Welcome back to Mining of Massive Datasets. We're continuing our discussion of online algorithms. Now, we just warmed up by looking at an online algorithm called the greedy algorithm for the bipartite graph matching problem. We're going to look now at an application of online algorithms, which is performance-based advertising. And in particular, we're going to look at a problem called the AdWords problem. Let's start with a short history of advertising on the web. Now, from the web advertising started almost simultaneously with the World Wide Web itself. And in the early days of the web, the only kind of ads that you see online were banner ads. And these reigned supreme from till about 2001. And banner ads were very, very simple. They were graphical units that you saw on web pages. And popular websites charged a certain number of dollars for every 1,000 impressions of the ad. This is called the CPM rate, or the cost per 1,000 impressions, where M is the Roman numeral for 1,000, and that's why it's called a CPM rate. And this model comes to us from TV or magazine ads, which are priced similarly based on the circulation of the magazine or the number of viewers of a TV show. This is a good initial model to start off with. But it doesn't really, exploit a lot of information that we have available on the web that we don't have available, on TV or in a magazine ad. In particular, these ads are very, very untargeted. So the same ad is shown to everyone who comes to a website or sees a particular page on a website. And so these ads, not surprisingly, perform really, really poorly. Now, how do you measure performance? Typically, advertisers measure performance of ads by looking at how many people click on the ad. What they look at is what's called the click-through rate, which is the ratio of the number of clicks the ad receives divided by the number of impressions of that ad. Remember, impressions are what the advertiser is paying for in the CPM rate, and the clicks are what they want. And so they measure the return on advertising, return on investment, or ROI, by looking at the ratio of clicks to impressions. Not surprisingly, the early banner ads, which are completely untargeted, have very low click-through rates and very low ROI for advertisers. And this sort of prompted a move of banner advertising that went from untargeted and then it kind of moved to demographically targeted. You can sort of get demographic information, broad demographic information about the kinds of people who are likely to see a given web page and target ads to those people. For example, you can place automotive ads on a site about car repair, for instance, right? So you can sort of broadly demographically target ads to specific websites. But in general, these ads still don't perform really well because they are very broadly targeted. Now, all this changed with the advent of a next new form of advertising called performance-based advertising. And performance-based advertising was first introduced by a company called Overture around the year 2000. Now, a lot of you may not remember Overture, but it was another search engine, that existed around the year 2000. And their innovation at Overture was that they allowed advertisers to bid on search keywords. So people searched on Overture, much as they search on search engines like Google and Bing today. And advertisers bid to appear on those search results by bidding on specific search keywords. And when somebody searches for that keyword, then Overture used to show the ad of the highest bidder followed by the actual search results. But the key innovation that Overture made was that the advertisers was charged only if the ad was actually clicked on. Right? The advertiser did not charge, did not pay for the impression, but they paid only for the click. And so this is called performance-based advertising, or cost per click advertising, to distinguish it from the impression-based or CPM advertising that preceded it. Now, it turned out that advertisers really liked performance-based advertising or CPC advertising, and Overture did really well and ended up being acquired by Yahoo much later on. However, Google, which was another search engine which was getting started at roughly the same time, adopted a very similar model to Overture's around 2002, and they call it AdWords. Now, we're all familiar with AdWords when we search on Google today, when we see these ads on Google, which are ads that are targeted to the searches that we do. The idea originally came from Overture and was then adopted by Google. Now, as we will see, Google made some important changes to the Overture model in terms of how advertisers bid and what ads get shown. Now, it turns out that performance-based advertising actually works. Advertisers really like to pay only for clicks as opposed to impressions. And so it is a multi-billion-dollar industry, primarily around search marketing. And there are a number of algorithmic challenges around performance-based advertising. There are, they roughly fall into two buckets. The first bucket is from the point of view of a search engine, which is what ads do I show for a given query? And that's the topic of today's lecture. And the second set of challenges come from an advertiser point of view. And the problem here is if I'm an advertiser, which search term should I bid on and how much should I bid for those search terms? Now, this is not the focus of today's lecture, but it's in fact a very important problem, and there's an entire industry segment that focuses around this problem as well. So we formalize the problem from the search engine's point of view. We call it the AdWords problem because it was originally formulated in the context of Google's AdWords. And in the AdWords problem, a stream of queries arrives at a search engine. And let's say that's Q1, Q2, Q3, and so on. And in general, a search engine knows the queries that it has seen so far, but it cannot predict the queries it's going to see next. Now, several advertisers have bid on each search query. When a query QI arrives, the search engine must pick a subset of advertisers whose ads are shown. Right? When you search, there's a number of advertisers who bid for that keyword. Now, there's usually a larger set of advertisers that have bid for a keyword than the search engine can show. Most search engines have a policy that said they will show at most one ad or two ads or three ads for each search query. There may be tens or hundreds of bidders for each search query. So the search engine must decide which subset of advertisers it will pick and show their ads for that search query. And remember, this looks very, very similar to the model for bipartite graph matching, and it's no coincidence. The goal is to maximize the search engine's revenues by showing the appropriate set of ads. And clearly, we need an online algorithm in this case because the search engine can only see one query at a time, and it must make an irrevocable decision of deciding which ads to show, but it cannot go back and change the ads it showed in the past, nor does it know what queries are going to come in the future. So we need an online algorithm for this problem, very similar to the algorithm that we had for the bipartite graph matching problem. Now, it turns out that there is a very simple heuristic that you can use to create an online algorithm for the AdWords problem. And that heuristic is called expected revenue. Let's first look at a very simple example. Let's say we have a particular query Q, and we have three advertisers, A, B, and C, who have each bid on query Q. And their bids are shown in this table here. Advertiser A has bid $1 for each click. Advertiser B has bid 75 cents for each click. And advertiser C has bid 50 cents per click. Remember now, these are bids per click. So if the search engine decides to show advertiser A's ad, then advertiser A pays if there is a click at that time. The advertiser A doesn't pay anything if the user doesn't click on the ad, but the ad just gets shown. Right? Now, the search engine doesn't know a priori whether the ad is going to get clicked or not. So the simple heuristic that Overture used when they first introduced performance-based advertising was to just show the ad from the highest paying advertiser. They used to sort advertisers by bid, as shown here, from top to bottom. So advertiser A has the highest bid, advertiser B has the second highest bid, and advertiser C has the third highest bid. So if I'm going to show only one ad, I might as well show advertiser A's ad because advertiser A is willing to pay the most per click. where if I'm going to show two ads, I should just show advertisers A and B's ads, but not C's, because A and B are both willing to pay more than C for each click. So this is a simple heuristic that Overture used for deciding which ads to show. Now it turns out that this is not the optimal algorithm for this scenario, and the important reason is that ads behave very differently in terms of how they get clicked. So what we should instead measure is something called the click-through rate of each ad. Now suppose advertisers A's ads, on average, let's say we show all these ads many times and measure how often they're clicked. Let's say advertiser A's ads are clicked 1% of the time, B's ads are clicked 2% of the time, and C's ads are clicked 2.5% of the time, right? Now, if I show advertiser A's ad and it's just clicked 1% of the time, then each time I show advertiser A's ad, there's a 1% chance it's going to be clicked. And if it does get clicked, I get paid $1. And so my expected revenue from showing advertisers A's ad is $1 times 1%, which is a penny, right? And similarly, my expected revenue from showing advertisers B's ad once is 75 cents times 2%. And similarly for C, my expected revenue is 50 cents times 2.5%. And so we can go ahead and compute the expected revenue for each advertiser by multiplying their bid and their CTR. And in this case, we find out that the expected revenue for advertiser A is 1 cent, the expected revenue for advertiser B is 1.5 cents, and the expected revenue for advertiser C is 1.125 cents, right? Now, the important innovation that Google did that beyond the model that Overture had introduced was to observe this and notice that it's much better to sort advertisers by expected revenue than it is to sort them by bid, right? So when you sort by bid, you place advertiser A first, whereas when you sort by expected revenue, you observe that advertiser B is actually a much better advertiser's ad to show. So if we just had to show one ad, you'd much rather show advertisers B's ad because their expected revenue is 1.5 cents, as opposed to showing advertisers A's ad where the expected revenue is just 1 cent. So in fact, if you sort by expected revenue rather than actual bid amount, you get a different sort order with BCA instead of ABC. And this is in fact the AdWords innovation that Google introduced. It turns out that sorting by expected revenue is a very good heuristic, and it works well for the AdWords problem. Now it turns out though that there are a few more constraints in the AdWords problem that just the sorting by expected revenue doesn't solve. Let's look at some of those constraints. So let's formally state the AdWords problem. We are given a set of bids by advertisers for search queries. Now we just looked at one search query, but in general, remember there are many search queries, and there are many advertisers, and each advertiser bids for some set of search queries. So there's a set of bids by advertisers for search queries. You can think of this as a bipartite graph with advertisers on one side and search queries on the other, and there are edges between advertisers and search queries. We are also given a click-through rate for each advertiser query pair that has been estimated. Now the new thing that we haven't seen so far is that each advertiser has a budget, right? Now advertisers don't have infinite advertising budget. Advertiser might say, look, I'm willing to spend at most $1,000 a day, or I'm at most willing to spend $100,000 a month, or $1 million a month. But there is always a limit to how much an advertiser can spend, which is defined by their advertising budget. So each advertiser has a budget which they tell the search engine. Now the search engine also has a limit on the number of ads to be displayed with each search query, right? For example, the search engine may say, look, I'm going to show at most one ad for each search query, or 2 or 3, Now, in some modern search engines, the number of ads actually depends on the kind of query as well. But in a simple scenario, let's imagine that there is a fixed limit on the number of ads to be displayed with each search query. Now, the AdWords problem is then given all these to respond to each search query with a set of ads. And we have to find a set of ads so that the size of the set is no larger than the limit of the number of ads per query, right? And we also have to make sure that we only show advertisers who actually bid for the search query. Otherwise, we are not going to get paid. And finally, and most critically, we have to make sure that not only has the advertiser bid on the query, but the advertiser has budget left over to pay for the ad if it is actually clicked upon. Right? If you show an ad from an advertiser whose budget has been exhausted because lots of ads have been clicked on from that advertiser, then if somebody clicks on the ad, then the advertiser doesn't have enough budget left over to pay for the ad when it's clicked, then the search engine doesn't get paid, so there's no point showing that advertiser's ad. So once the budget of an advertiser has been exhausted, we can effectively assume that the advertiser is out of the game and is no longer bidding on any search queries. So the AdWords problem is therefore to find a set of ads for each search query that satisfy these criteria. So here's a simple algorithm that we've seen, which was to sort by expected revenue, which is bid times CTR. And it turns out that if the CTR of each ad is known and if advertisers have unlimited budgets, then the simple algorithm, which is to sort by expected revenue, is actually optimal. However, advertisers don't have unlimited budgets in practice, and the CTR of an ad is unknown, so we have to do something different. Let's start with problem one, which is to estimate the click-through rate of an ad. And in the next lecture, we'll look at an algorithm called balance, which deals with the fact that advertisers have limited budgets. So look at the problem of estimating the click-through rate of an ad. Now, this looks like a very simple problem. All we have to do is to measure the click-through rate of a query ad pair historically. We just have to show an ad a large number of times, right? Let's say 1,000 or 10,000, and we have to measure the number of clicks for that ad, query ad pair, and then we have the CTR for that query ad pair. And so far so good. This is in fact the right way to do it, but there are a couple of challenges which we actually won't have time to cover in this lecture. The first is that the click-through rate is actually position dependent. So remember, a search engine may show more than one ad for a given query. So an ad that's shown in position 1 generally gets more clicks than an ad that's shown in position number 2, right? So therefore, we actually have to measure the click-through rate for a query ad pair for each position, not just for a query ad pair, because the CTR is position dependent. And the second problem that we have is something called the explore v exploit trade-off. Now, imagine that we have a lot of ads for a given query, and we've shown them a lot, and we know their CTR. And now a new advertiser comes in and also bids on the query. Now, we don't know the CTR of the new ad. However, we know the CTR of the old ads. Now, should we show the new ad at all and take the risk that it doesn't get clicked on much and we lose some revenue? Or should we just ignore the new ad, just go with the ads that we already know their CTR and keep showing them to optimize revenue, right? Should we just exploit the known information, the known CTRs, the known ads, or should we explore what the new ad does? Perhaps the new ad is really good and has a high CTR, but we don't know. Perhaps it's actually bad and has a low CTR. So this problem is called the explore v exploit trade-off, and it's a very richly studied branch of research, which again we won't have time to cover in this lecture. We'll just assume that we know the click-through rate for each query ad pair because it's been given to us.